All right, let's dive right in. Today, we're looking at a theory that poses a really huge question. What if the fundamental rules of our universe, the ones we take for granted, aren't just abstract laws, but are actually the result of a single physical mechanism?
I mean, think about it for a second. Why does stuff that's moving stay moving? Why does time itself seem to slow down the faster you go? What if these aren't just weird separate rules we just have to accept? What if all of these fundamental laws,
from something as basic as inertia
to something as mind-bending as time dilation?
And yeah, even the super weird fact that energy only comes in these little distinct packets? What if all of it, the whole shebang, springs from one single physical explanation?
Okay, so here's the situation in physics today. It's incredibly successful, right? But at its very foundation, there's this sort of just accept it problem. We've got these core ideas, these postulates, that work perfectly, but they don't really come with an owner's manual explaining why they work.
For a long, long time, physics has been all about assume this, then calculate that. We just take it on faith that an object in motion stays in motion, or that the speed of light is a constant. And these assumptions let us build these amazing theories and make unbelievably accurate predictions. But it kind of kicks the can down the road on the biggest question of all. Why are these the rules to begin with?
Okay, so this is where a fascinating new idea called dual vacuum field theory, or DVFT, steps onto the stage. It starts with one big, radical idea. The vacuum of space isn't empty. Not at all. It's a real physical thing, a medium that everything else in the universe is made of. Now, according to the theory, this vacuum has two essential properties you can't pull apart. First, you've got amplitude. You can think of this as the raw stuff of the vacuum. Its potential to just be, to exist, to hold energy. And then there's phase. This is its ability to change, to wiggle, to evolve over time. You could almost say phase is what makes time possible.
And what's so elegant is that you logically have to have both. It's just common sense when you think about it. As you see here, if you only had amplitude, you'd have a universe full of stuff, but it would be frozen solid, a dead universe. On the flip side, if you only had phase, you'd have the potential for change in motion, but with absolutely nothing there to actually change or move. It's only when you put them together, amplitude and phase, that you get a universe that can both exist and evolve, a living universe.
So how does this one big idea change everything? Well, if space really is a physical medium with these properties, then suddenly all those fundamental rules of physics stop being rules you just have to accept. They become unavoidable consequences. It's like tipping over the first in a long, long line of dominoes.
Okay, let's take inertia. We're all taught that things just resist changes in motion. It's a rule. But this theory says, no, it's a physical interaction. It's the vacuum's own stuff, its amplitude, literally resisting being changed too quickly. From this point of view, mass isn't some intrinsic property. It's just a measure of how much an object is disturbing the vacuum right around it.
And what about time slowing down? Relativity tells us it's a geometric effect of space-time. But DVFT proposes something more direct. It's a physical process. Time literally is the rate at which the vacuum's phase is evolving. When you move fast or you're near a massive object, you're essentially making the local vacuum denser, which physically slows down that evolution. Your clock doesn't just look like it's slowing down. The fundamental process of time itself is running slower for you.
And that leads perfectly to the next point, the speed of light. Why is it always the same, no matter what? Well, relativity just says it is. It's a postulate, but this theory gives a physical reason. The speed of light is simply a material property of the vacuum itself, a ratio between its stiffness and its inertia. It's no more mysterious than the speed of sound is in water or in steel. It's just a property of the medium.
And now for what might be the most beautiful explanation of all, quantization. The bizarre fact that everything in the quantum world comes in these discrete little chunks. Well, in this theory, phase isn't just some number. It's angular. It works like a circle. And because of that, only stable, whole number windings in the vacuum's field can actually exist long term. You can't have half a winding. So quantization isn't some weird rule imposed on the universe, it's just a natural outcome of its basic geometry.
So this idea doesn't just stop with the small-scale rules. It completely reorganizes how we could look at the entire cosmos and some of its greatest puzzles.
Right now, two of the biggest things in cosmology are the hunt for dark matter and dark energy. We're looking for new particles, new forces, but what if they're not things at all? In this model, what we call dark matter could just be the large-scale behavior of the vacuum's phase swirling around galaxies, creating extra gravity without needing extra stuff. And dark energy? that could just be the vacuum itself, regulating its own expansion on a cosmic scale. Suddenly, the mystery isn't about finding new things, but about better understanding the thing we're already in, the vacuum.
Now, it's really important to be clear about what this kind of idea would not do. This isn't about throwing a century of physics in the garbage. If DVFT holds up, it wouldn't prove quantum field theory is wrong any more than Einstein proved Newton was wrong. It would just give our incredibly successful theories a deeper, physical foundation to stand on. And it definitely wouldn't mean we can stop doing experiments. If anything, it would give us a ton of new, exciting things to go out and test.
So ultimately, the biggest impact of a theory like this wouldn't just be about the equations. It would be a huge cultural shift in how we understand what reality even is.
And this quote on the slide really just nails it. It's a reorganization, not an overthrow. The math that works so well today would still work tomorrow, but it would be connected to a physical reality. We'd be swapping out abstract axioms for real, tangible mechanisms.
This leads to a really profound concept the theory calls coherence. It suggests that things we think of as the absolute bedrock of reality, time, mass, force, they aren't actually fundamental. They are emergent properties. They pop into existence because of something even deeper, the way the vacuum's phase behaves and holds itself together.
And this framework offers a really elegant answer to that age-old question, why is math so ridiculously good at describing the universe? The answer it gives is simple and kind of beautiful. It's because the universe itself is built on a mathematical structure, the fundamental geometry of phase.
And that kind of leaves us with the final, big, provocative question. For so long, the basic rules of the universe have felt a little bit like miracles, right? Things we just had to accept without a real why. This framework asks us to consider a different possibility, that reality isn't a set of miracles, but a single, magnificent, and ultimately understandable mechanism, just waiting for us to figure it out.